Black hole mergers defying our understanding of physics? What's up with that?
An ultra-massive black hole has just been measured, and the number has left the entire astronomical community in shock, over 36 billion times the mass of our Sun. It's so large it shatters every concept physics once thought possible, forcing us to rethink our entire understanding of how galaxies form and perhaps even the Big Bang itself. But what worries scientists most isn't its size. It's the object's absolute silence and mystery. A black hole with enough power to warp the very fabric of spacetime has somehow vanished from nearly every form of radiation. How can something powerful enough to shape the cosmos hide itself so perfectly? This story begins with a rather unassuming name, SDSSJ148 plus 1930, or simply LRG 3757, a galaxy at the heart of the famous structure known as the cosmic horseshoe. At first, no one thought it was special, that is, until a research team led by scientist Carlos R. Melo Carneiro at the Federal University of Rio Grande do Sul tried to measure the amount of dark matter within this galaxy and accidentally stumbled upon something inexplicable. When light from a more distant galaxy passes through LRG 3757, it gets bent by gravity, creating a horseshoe-shaped ring of light. This is a familiar effect in astronomy known as gravitational lensing. But when the team used data from the Hubble Space Telescope to simulate this phenomenon, they hit a wall. None of their models could reproduce the true shape of the ring. They tried changing every parameter from stellar mass and dark matter density to the structure of the galactic core, but the results were still wrong. Everything only clicked into place when they inserted an enormous, almost nonsensical mass right at the center. When the final number appeared, everyone was stunned. Approximately 36 billion times the mass of the Sun. Of course, a single model isn't enough for a conclusion. They needed an independent way to verify that such a colossal object truly existed at the galaxy's core. So, they turned to the MUSE instrument on the Very Large Telescope VLT in Chile to measure the velocity of stars near the center. If an ultra-massive black hole was there, it would have to be whipping the surrounding stars into motion at incredible speeds. And just as predicted, the stars in the core region were moving at up to 400 kilometers per second, 13 times faster than the Earth orbits the Sun. At that speed, without an immense gravitational anchor at the center, the entire region would have been flung apart into space long ago. Two independent sets of data, the lensing image and stellar motion, both led to the same conclusion. At the center of LRG 3757 lies an ultramassive black hole, weighing in at 36 billion solar masses. When they tested the statistical confidence, the result was 5 sigma, meaning the probability of this discovery being a random chance is less than 1 in 3.5 million. In astrophysics, that is as close to absolute certainty as it gets. What makes this discovery truly extraordinary is that the black hole is completely silent. It has no blazing accretion disk, emits no detectable light or radiation, and isn't eating surrounding matter like the quasars we often see. And yet, its gravity is powerful enough to bend light itself and force nearby stars into a terrifyingly fast dance. It is a true sleeping monster, gargantuan, invisible, and utterly still. The discovery was published in the monthly notices of the Royal Astronomical Society and quickly spread throughout the scientific community. Melo Carneiro's team was thrust into the spotlight, not just for the 36 billion solar mass figure, but for how they measured it, a technical feat that would have been nearly impossible just a few years ago. Instead of waiting for the black hole to shine, they found a way to see it through the dent it leaves in spacetime. This technique, combining gravitational lensing modeling with stellar kinematics, is a revolutionary breakthrough. It allows scientists to weigh inactive black holes, objects that were previously completely invisible. Instead of seeing the light a black hole emits, they read the signature its gravity leaves on light from elsewhere. It's like not being able to see a dark object in a room, but knowing it's there by the way the wind has to curve around it. The initial models were built on Hubble data, then verified with spectroscopic observations from MUSEVOLT, which measured the velocities of the stars. When the two datasets matched perfectly, the team knew they were onto something real. And that result, though confirmed with 5 sigma confidence, is just the beginning. Astronomers immediately began planning to use more powerful instruments to peer deeper into this system, from the James Webb Space Telescope and the ESA's Euclid telescope to the extremely large telescope ELT, currently under construction in the Atacama Desert. The goal isn't just to reconfirm the mass, but to find signs of similar objects in other galaxies. If even a few more similar discoveries are made, we will have a completely new population of objects on our hands, ultra-massive but non-luminous black holes. Invisible giants that could be governing the structure of the entire universe without our knowledge. That also means our current cosmological models, which assume that most of the universe's hidden mass is dark matter, may need to be revised. It's possible that a fraction of the dark matter we thought was some exotic particle is actually these undiscovered, colossal black holes. Some physicists, including Avi Loeb of Harvard, have long posed a bold question: if primordial black holes are common, could they be the dark matter we've been searching for? The discovery at the cosmic horseshoe isn't enough to answer that, but it makes the question seem far less radical than it once did. And this is perhaps the deepest meaning of this finding. It's not just a record-breaking number or a beautiful image, but a fundamental shift in how we see the universe. We've moved from only observing what shines to learning how to observe what doesn't, reading the subtle wrinkles in the fabric of space, where gravity writes the stories that light dares not tell. However, as the final data was locked in, the story got even stranger. The data didn't just confirm the black hole was real, it showed that it was far larger than our models of the universe should allow. According to conventional understanding, black holes are the final products of massive, dying stars. When a sufficiently heavy star dies, its core collapses under its own gravity to form a black hole. These black holes then grow over billions of years by pulling in surrounding matter gas, dust, and even smaller stars. But for LRG 3.757, a mass of 36 billion suns suggests that this growth process must have happened dozens of times faster than any current model predicts. This raises an uncomfortable question: if it didn't have enough time to eat its way to this size, then how did it form? Could it have been born before its own galaxy? That question sounds like a paradox. But it's at the center of a debate that has been simmering for years. For a long time, astronomers believed that galaxies and their central black holes grow together in lockstep. But extreme cases like LRG 3.757 are starting to bend that once unbreakable line. One theory suggests this galaxy is the product of countless mergers. In the cosmos, galaxies are constantly colliding and merging, especially giant elliptical galaxies. Each time they do, their central black holes spiral towards each other until they unite. Repeat this over billions of years, and the end result is a merged giant and ultra-massive black hole, just like the one we see in LRG 3.757. This scenario sounds plausible, but it fails to explain why the black hole is almost completely inactive now. If it were truly born from a series of violent collisions, where are the scars? There's no accretion disk, no relativistic jets, no signs of high-energy activity. It's like a colossal star that is burned out still there, but utterly silent. Another, more audacious theory proposes that these ultramassive black holes appeared at the dawn of time. They weren't born from stars, but before stars as primordial black holes, formed just moments after the Big Bang when the universe's energy density was extreme. According to this theory, primordial black holes were the earliest seeds, pulling matter around them to form the very first galaxies. If that's true, then the discovery at the cosmic horseshoe isn't just a record breaker. It's evidence for a completely new direction. Perhaps it was black holes that created galaxies, and not the other way around. Viewed this way, the silence of LRG 3.757 is no longer a mystery but a sign of its immense age. It no longer needs to accrete matter, has no more fuel to burn, and has reached a state of stable equilibrium. It's an ancient relic, a cosmic fossil left over from the era when the first structures in the universe were just beginning to form. Whichever explanation you choose, this discovery is a blow to what we thought we knew for certain. It forces scientists to rewrite the very first line in the story of cosmic evolution: in the beginning, before the first galaxies existed. Perhaps it was the black holes that started it all. For decades, astronomy has been synonymous with light we capture, analyze, and decode every form of radiation the cosmos emits. But this discovery shows that the universe doesn't only tell its stories with light, it also speaks with gravity, with minuscule distortions in the structure of space, with warped rings of light that, only when we look closely enough, reveal a force powerful enough to bend space-time itself. From a blurry photograph, we have heard the voice of gravity, and because of it, we now know a gargantuan monster lies sleeping in the void. It doesn't shine. It makes no noise. It exists only by the sheer weight of its being. This has made the scientific community realize something profound every time we discover a phenomenon that defies our models. It isn't an endpoint, but a starting point. The black hole at the cosmic horseshoe raises far bigger questions than it answers. How many other black holes are hiding like this? Could they make up a portion of the mysterious mass we call dark matter? And if the universe is filled with such silent giants, then the picture we see today is only a tiny fraction of the whole. The further we explore, the more we understand that knowledge isn't a destination, but merely a temporary step out of the next region of darkness. It may take decades, or even a century, to fully grasp the meaning of this discovery, but that is precisely why we continue to look up at the sky. Because while the light shows us where we are, the darkness shows us how much is left to be seen. And if you want to continue that journey, a journey through light and across darkness, to listen to the stories the universe is still telling through its silence, be sure to like, subscribe, and join us for the next chapter. Because with the universe, this is all just the beginning.